silence.
Yes, guys, we're going through a hard time during this corona period.
I totally agree with you.
Yeah.
And in fact, you remember that mathematics, it is the language that we do all know. Yeah, and it is a daily language.
Daily language. I remember I was given 5 kwacha today and I used the 2 kwacha. It's 3 kwacha.
Yeah, you use so subtraction.
Yeah, subtraction. I subtracted.
So guys, this page is kind of created for you and for us. We are here to learn from you and you are here to learn from us. There is no teacher, but as we are interacting, we need your total participation. As you are watching, please share this video. Share this video so that even other people can learn from us and we can also learn from you. Do remember to share. Please, we are begging you, share this video to a cousin or any person you know that he needs this information. We all need this information to sustain our academic. We know that we've gone through hard times during this COVID period. There are some lockdowns and we just came up with this idea. You know that, right?
Yes, and many of us may have lost hope in studies. Or maybe thinking, no, we are behind with the syllabus and there are many things that are yet to be done. But fear not, that is why we have this platform.
Yeah.
We will share the knowledge that we have and get 2 or more things from you guys.
Yeah.
So at the moment, I'm going to leave you with my friend here. Have a great time, but follow the COVID-19 measures. And to just be as an example, we also have the sanitizer.
Yeah.
We sanitize
Please
regularly.
remember to sanitize regularly.
And also, guys, mask up.
Yeah, remember to mask
up.
Yeah, make sure that you sanitize so that we can fight this pandemic as we are going through these hard times.
So guys, I'm still with you, but for now, I'll be in the background. Enjoy the lesson.
Thank you. Yeah, okay. Today we're going to look at sets. As an introduction, we know that mathematics, my friend earlier has introduced what mathematics is. Mathematics is a human language. In fact, mathematics is everywhere. You can't live without mathematics. You can't live in daily basis without mathematics. Even in the Bible there is mathematics. Remember numbers, it all involves mathematics. So mathematics is not a difficult subject, but it is a subject that we do in our daily basis. Now, according to Zambian syllabus, we're going to start with about sets. We all know sets. And set, I can define a set as a collection of well-defined collection of objects. It is a collection of well-defined objects. What are those objects? We see many sets in this world. We see so many sets in this world. So now I'm going to give you an example of sets. I'm going to show you an example. So here I am having a set. This is a set of calculators. I have different kinds of calculators. This is a set. As we've defined the set, it is a collection of well-defined objects. I've defined this object as calculators. So we all know that this is a set. Is that understood? If it is understood, I have another example. I have a mathematical set. I have a mathematical set which consists of collection of objects. What are those objects am I talking about? These objects I'm talking about are mathematical instruments. As you can see, these are well-defined objects. So these are collections. They are collected in this set. A set of pens. This is a set. I have collections of defined objects. These are sets. Now guys, remember that. Okay? Remember that as we are going to start this lesson, I need your participation and total attention so that we can understand this simple topic. It is a simple topic. Don't let someone fool you that mathematics is a difficult subject whereby you need to do what and what. No. Here mathematics, we are simplifying it. Make sure that you share this page. Make sure that you share so that we can broaden our knowledge. Because mathematics is not difficult as you are according it. Now, today's concentration, I want to tell you that we are going to concentrate about 2 things. Later on, we are going to move back step by step. But remember that as we are studying, we don't need someone to say, oh, I need algebra, or he posts a question on algebra, but we are on set. So we need you to be following this lesson step by step. If we are on set, oh, I've not understood this, you ask the question and we'll explain to you. So today we're going to concentrate on two things about these sets. So we've defined the set. Secondly, we are going to understand about set notations. Secondly, we are going to look at sets of numbers. Another time you'll be with my friend. He will teach you about other things. But today we're going to concentrate on two things. I've said set notation and sets of numbers. Okay, so we start. A set is a collection of well-defined objects. And each object is called a member or element. Now, when you have a set, I had a set of calculators. Each object has its name. I had a set of calculators. Those calculators are different names. I had Sharp calculator, I had Casio, so many different names, but it is a set. So understand in that way. In that way, we're going to understand more on the sets. Now, I've said that we are going to look about the two most important things about these sets. Now, the first one I said, it is set notation. How can you notate a set? How can you know that this is a set? How can I know that, oh, this is a set? Now, worry not, because a set is denoted by a curved bracket. These are curved brackets. If you don't know how to write them, please practice how to write these curved brackets. Because if you don't know them, a set cannot be denoted by an open bracket. You can't say that this is a set. So for you to show them that you know mathematics, show them that this is a curved bracket. That's how you can know that this is a set. Is that understood? Or perhaps my mask, I'm not audible enough. Maybe let me remove the mask for a moment, but I'll also observe COVID-19 measures. So a set is denoted by a curved bracket. These are curved brackets we are talking about. So for you to know that this is a set, you identify the curved brackets. Okay, we move on. Okay, where the members are defined inside the set and denoted by a capital letter. A set is denoted or noted, it has curved brackets, and it is defined, the objects are defined inside, and a set is denoted by a capital letter. You can only denote a set by a capital letter. Example, this is a set. These are the things that are proving to us that this is a set. One, it is denoted by a capital letter, A. So we don't want a case or a situation whereby our dear lovely viewers, you are writing a set starting with a small letter. So you need to start with a capital letter. That will show that you are talking about a set. So this is a set, and it is denoted by curved brackets. Please, we don't need someone to write the open bracket to show that this is a set. No. Remember that a set is denoted by curved brackets, and each element or member, remember an element is contained inside the set. What we have is an element or a member inside here. So X is a member. I had a set of calculators, Sharp calculator, Casio calculator. Those are members and elements. So this is an element here, and we have this one is denoting a set and represented by a capital letter. These are curved brackets, which are defining the members that are inside. Another example we have here, a set. So a set can be a collection of well-defined objects, any objects. You can group any different kinds of objects, so long they are defined, well defined. Okay, we move on. Now, the number of elements in a set is denoted by this. So these are important exam identifications that you can identify in an exam group. A set is denoted, or a member of the number of elements in a set is denoted by this. There is no way we can denote a number of elements in a set minus knowing this concept. So you need to know this concept, that the number of elements in a set is denoted by this. In exam questions, you will see this. The question will just say, find this. What are they talking about? What are they implying? Do I know this concept? Why not? No wonder we are here. It is to learn. This, when you say this, they are saying number of elements. Now, remember that a set is denoted by a capital letter. Any capital letter from the alphabet, it might be B, it might be, or any letter. Don't be confused. Know that this is talking about the number of elements in set A. That's what it's only talking about. So, number of elements in any given set is denoted by this. They will not use any language to say that, oh, they are talking about number of elements. These are very, very important points. Starting from board 1, we are talking about important things. So remember that these things we are talking about, they are examinable. Okay? We move on. An example. How many number of elements in the following sets? How many number of elements? So we've said that the number of elements, we know the elements. I've given an example, elements of a set of calculators. I've talked about, we have Casio, Sharp, and the other calculators. You saw that I had 3 calculators. Now here we are talking about the elements in a set is denoted by this. Now, how many number of elements in the following set? How many elements? So, no need to worry, no need to struggle. Mathematics is simple. What you need is practice. Mathematics is not the subject for lazy people. As you are our dear lovely viewers, please remember that you need to practice. As we go on, invite other friends. Share this page so that we can learn more, we can share ideas and make mathematics simple. It is a simple language, So we are saying that number of elements is denoted by this. Now, example here is saying, how many number of elements do we have in this set? In this set, I've laid a platform whereby we know that this one is a set, a capital letter, curly brackets. No one can force that this is not a set. So now, how many number of elements? So let's look at the solutions. Excuse me, I want to get a chalk. Okay. Now, if this is a set, they are telling us to find the number of elements in this set. Not an element in chemistry for sure. I know some people, they are an element in chemistry. So, but this one is a different case. We're talking about an element using mathematical language. Okay? So now, how many number of elements in this set? So, the first solution we are going to say is that number of elements in this. Remember that number of elements is denoted by this. So, we are going to write number of elements in set A. So, we are looking for number of elements in set A. So, for us to know the number of elements in this set, we are going to count. Because we're going to count. As simple as drinking water. It is simple. Mathematics is simple. We're going to count. 1, 2, 3, 4, 5. Is the answer clear? 1, 2, 3, 4, 5. So the answer is 5. This is the answer. You've given them the answer. So that's the answer. We go on to question, the second one. How many number of elements in this set? This is a set we know. This is a set. Now, how many number of elements? We know that elements are in a set. These are elements. And they are distinguished by a comma. So, we are going to count. 1, 2, 3, 4, 5, 6. So, the answer is just clear. So, number of elements in set B is equal to 6. Very simple. Very soon we are going to tackle exam questions. We are going to tackle exam questions. And these questions will be based on this foundation I'm laying. Please don't forget, these are examinable questions. And these are technologies that you're going to use. So I would like you to master and understand these things as we are going. Master these things and know them. Okay? So let's go to another part of our today's lesson. So another set we are going to look at is symbol meaning, or the meaning of symbols in sets. Know these symbols, understand them, they are very simple and clear. Understand them, know them, and please do remember that these symbols have meaning. And so I was saying that for you to know these symbols and for you to understand them, we have this example. So in sets, you come across these symbols. You come across these symbols. For knowledge's sake, we need to understand them. We need to know them. We have to know them. We have to know them. Now, the symbols have meanings. Now, the symbol I'm going to start with is a member of or element. So this symbol, usually what it means is here. It is a member of or element. This symbol, when you see this symbol, is different from when you write a capital letter E. It is different. Please do take note of how I'm writing it. It is not capital letter E. It is different. It's a mathematical symbol. Its meaning is member of or elements. Now, an example here is saying X. So you read this symbol. What is the meaning of this symbol? So you say X. Okay, we're going to start an example. So X, you write this. This is a set. Remember, this is a set. We are denoting it by a capital letter. So for us to read it, we are going to say X is a member of or an element of set E. That's how we're going to read it. X is a member of A. This is a set. X is a member of set A, or X is an element of set A. So it is as simple as that. Know this symbol, understand it, and know its example and what it symbolizes. Don't worry, we'll answer questions that involve this symbol, and you know that it is as simple as drinking water. Second symbol we're going to look at is this subset. C, capital letter C. What it means is it's a subset. This simply means that this is a subset. Later on, we're going to look at its meaning now on set description. We're going to describe these sets. Now, we're going to look at this set when we describe the set. Okay? So, this is a subset. So, don't let anyone feel, do you know a subset? What is the symbol? What is the what? Why not? We are here to learn. I'm here also to learn from you. Please remember to share. Share this so that we can have many people participating in this. We've suffered a lot and we are here because we want to know, we want to learn, we want to explore. Okay? So, this is a subset. An example I'm going to give, but don't worry, we are going to describe more on description of sets. We're going to look at the sets now, how we can describe them. So, subset, don't worry, you understand it further. So, this is just to give you an insight. I'm just giving you an overview of what we cover. So, A, this is a set, remember. It is denoted by capital letter. I'm standing on the background. Okay? So, set A is a subset of B, if you want to read it. Set A is a subset of set B. What does it mean when they say A is a subset of set B? Don't worry, we'll tackle it, but I'll give you an overview. So, this simply means that this set is a subset. So, mean it is contained in set B, but don't worry, we'll look that further when we go to set description. Now, if you want to read it, set A is a subset of set B. Okay, we move on to another one. So, this one is the opposite of a member of. So, this one is not a member of or an element. Okay, so if we look at the example, so X is not a member of or an element of set A. So if you have set A, I had sets of calculator. If I say sharp calculator, I'm referring to a calculator. Sharp is not a member of sets of A. If example that set was a set of calculators, so meaning in that set I had, there was no sharp calculator. That's what this simply means. In that set I have, there is no sharp calculator. That's what it simply means. Very simple. Just understand it. Share and do practice as we are going on. Okay? To read it, X is not a member of or an element of set A. Okay? We move on. The fourth one is not a subset. So it's opposite of this. It's not a subset. Excuse me. It's not a subset. So set A is not a subset of set B. So this one, set A is not contained in set B. Don't worry, we'll further examples on when we start describing these sets. So set A is not a subset of set B. That's how you can read it. The fifth one is the equal to symbol. We are familiar with this one. We all know it. But for the sake of knowledge, there might be someone who might be doubting, oh, can they use this symbol in sets? They can. More especially when we start looking at exam questions. Now, this symbol means equal to. So when they say set A is equal to set B, what it means is that set A is equal to set B. In an exam question, they can say this. What is the meaning of this? This simply means that number of elements in set A is equal to number of elements in set B. Don't be confused. We are laying a platform whereby that refanga to ayakuntanji umuntu kuisayisha nyatawe ine exam yachikosa because number of elements ishachishwe chama NA. No, we are here because we want to expand. We want to propound on this thing so that we can make this one simple. It is not difficult. It is not difficult. If I can understand it, even you can understand it. As simple. Okay? So this simply means that number of elements in set A is equal to number of elements in set B. So that's what that symbol was meaning. So to give a summary of one first concentration we are looking at was set notation. So this O is based on set notations. So you can notate a set by curled brackets, and the elements and the members are contained in it and are defined inside it. A set is denoted by a capital letter and curled brackets. We've looked at the examples. Number of elements in the set, those are the concentrations we are looking at in set notation. One, I've said that a set is denoted by curled brackets. Two, members of elements in a set, or the elements in a set are just counted for you to know the number of elements. You just count them for you to know the number of elements in a set. Those are the concentric areas, and symbol meaning, the meaning of symbols in sets. Now, I want to look at the second one. This is what we are calling set of numbers. Set of numbers. We have different numbers that exist. No wonder we are calling it set of numbers. Now, set of numbers, we have different sets of numbers. To start with, we're going to look at natural numbers. We're going to start with the natural numbers. Definitions are possible in mathematics because they will give you a knowledge and a background to stand. I'll know, we were talking about this, what are these? Definitions are important. Though they cannot ask you a definition in an exam, but they might ask you based on what you've understood. So, we are going to understand this set of numbers. To start with, we are going to look at natural numbers. What are natural numbers? What do you understand by the term natural? We all know what numbers are, but numbers here are specific. We have specified them to be natural numbers. What are natural numbers? Okay, natural numbers are numbers that we usually use when counting normally. Okay, I'll give an example. If we have a queue here, I cannot start to count that, 0, 1, 2. No, I cannot start with that. So I'll start 1 because we normally use it. These are numbers we use when counting in our daily basis. We don't count people like 0, 1, number 3, number 4. No, we start with 1. So you can understand this set of numbers by defining to this example, natural numbers. So natural numbers are numbers that we use for counting. We start 1, 2, 3, not to past 0. Because we don't refer to human beings as 0. Maybe it doesn't exist, that's what it means, if it is 0. So we start with 1. So these are numbers that we use for counting in our daily basis. So these are numbers, set of numbers. In an exam, they can ask you, they can just describe, okay? I won't go much further because when we start describing sets, now we are handling exam questions. But as at now, you understand. So make sure you understand this. Make sure you share. Make sure you view the video properly so that you understand what I'm talking about. If you are not clear, please leave the comment below. Leave the comment so that we can see and we help you how you can understand that what is it, where you are behind. So we are here just to learn. Don't feel shy. Don't feel no. If I comment, no. It is us, our responsibility. So this set of numbers we are saying, it starts with the 1, 2, 3, etc., etc. So these symbols means that it is an infinite set. So I won't talk about much on infinite set, but I will discuss them later. So these symbols means that the number is still going. They are still going. So set of natural numbers, they start from 1. Please understand this. Misconceptions comes here. Set of natural numbers starts with 1, 2, you go on, you go on. So that's the set, that's the natural numbers. Its symbol is this one. They can symbolize it like this. It's a set of natural numbers. It is a set of natural numbers. If we all understand these natural numbers, then we can go on to whole numbers. The difference here is that whole numbers, you can see the difference. Here we had no 0, but here we have a 0 appearing here. We have a 0. So these whole numbers, we know that 0 is a number, it exists. There is a debate that is 0 a number or not. But that one, don't worry. So the whole number starts with 0. Don't be confused when they say write a set of whole numbers starting from, okay, write whole numbers up to 12. You won't understand when they okay, man natural numbers very upon a whole numbers. Whole number which is 0 ila chita exist, 0 ila bamo na mtai bamo. But don't worry, just know that whole numbers they start from 0. Here is an inclusion of 0. We include 0 because whole number, we are referring to everything. Because if we say that 0, we won't include it on this set of numbers. What if someone writes 100? Why are we including these zeros? Or let's move these zeros. So this number won't make sense. So no wonder this set we are including a 0, because we know that it will feature on the hundreds, thousands, and millions. No wonder we are including 0 in this set of whole numbers. If that is understood, we move on to integers. 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 Alright? So these integers, these are numbers that we are including on this set, or that we have positive and negative numbers. Remember that we are looking at on sets of numbers. All these are sets of numbers that exist. That exist. So in an exam, you can arrive at the answer is giving you negative. Why is it giving negative? Is negative a number? Is negative 2 a number? In this lesson, we are saying that negative is a set of numbers. Negative is a set of numbers. So this, don't be afraid that unasanga shana answer negative. But because of negative is a number, is a set of numbers, so we are going to include it. Integers consist of negative and positive numbers. So these are integers. These set of numbers are very important. Know them one by one, understand them one by one. Okay? Denoted by this symbol, you know that this is an integer. Okay? So let's look at even numbers. Even numbers. These numbers are usually used in an exam. Now, what are even numbers? Even numbers. So these numbers are numbers whereby we can say 2 can go into them without leaving a remainder. That's how you can memorize it. These are numbers that can go into 2 without leaving a remainder. So they can go into these numbers without leaving a remainder. Okay? So 2 can go into 2 how many times? 1. 2 can go into 4 how many times? 2. So 2 can go into this number. Any number you think of that cannot leave a remainder when divisible by 2. So numbers that are divisible by 2 and does not leave a remainder, those are even numbers. Okay, we need to debate. Is 0 an even number? Is 0 an even number? What do you think? Can 0 be an even number? Okay, if we say 0 divided by 2, it will give us 0. When we say 0 divided by 2, we have a 0. Now, is it an even number? Okay, I'll pause that. We'll continue later that debate. Okay, so this is a set of even numbers. Okay, 2, 4, 6, 8, up to infinite. You find these are sets of numbers which we are calling even numbers. Okay, we look at now odd numbers. These are sets of numbers. Know them one by one and understand them, and you are able to classify them. Oh, all numbers, meaning we are including even 0 is included. Okay, integers are okay. I've learned about number line. Please, my number line is each time for negative number positives. So the set of numbers, numbers. Oh, what are even numbers? Oh, numbers that are divisible by 2 cannot give an and does not leave a remainder. Those are even numbers. Understand them, know them, make sure that you understand them. Okay? Odd numbers. What are odd numbers? What are odd numbers? So odd numbers, these are numbers when divisible by 2 and leaves a remainder. When divisible by 2 and leaves a remainder. So you can divide by 2 and it will leave a remainder. Here now, concentration here is 1 an odd number. Why are we saying that 1 is an odd number? Why aren't we saying that 0 is an odd number? I'll start with 0. If I say 0 is an odd number and we are saying it is only divisible by 2. So if I say 0 divided by 2, if this is an odd number, we leave a remainder. It will give a clear answer, 0. Where is the remainder? So odd number when divided by 2 gives a remainder. 1. When we divide 1 divided by 2, of course we are going to have half. So it is leaving a remainder, which is okay. So we cannot say that this is an 1 is not an odd number. 1 is an odd number, showing this. So these numbers, they can only be divisible by 2 and leave a remainder. So we start with 1 normal odd numbers. Yambila na 1, same applies with natural numbers. Yambila na 1. 1, 3. When we say 3 divided by 2, 3 divided by 2, we are going to have 1. Have this. So a 5 is a remainder here. So do you see where we are saying why we are saying that 1 is an odd number? Because there is a 5 remaining here. There is a 5 remaining here. When we go on 5 divided by 2, we have 2.5. A 2 will remain. So that basic still remains. Now, the misconceptions comes here. This 9. Is 9 an odd number? Or 9, is it not an odd number? This confusion comes in when on odd numbers and prime numbers. Confusion comes here between 9 and between odd numbers in 9 and 9 in prime numbers. Okay, so in odd numbers 9 is an odd number. When we say 9 divided by 2, we still have a remainder. So 9 proves that this is an odd number. So know the definition that odd numbers, where numbers are divisible by 2 and leaves a remainder. But different case from even numbers. Then they just give a whole number, which is between these numbers, a whole number they give this. Okay? 9 is an odd number. You can say 11. You can give 13. As so long it is leaving a remainder, that means it's an odd number. Okay. We move on now to prime numbers. Now prime numbers, we have these numbers. Okay? Prime numbers. What do you understand by the term prime numbers? What are prime numbers? So these are numbers that are only divisible divisible by 1 and the number itself. When we divide 1 into any of this number and the number itself, they will divide itself. So these are what we are calling prime numbers. An example, I can say, excuse me, I want to get a duster. Okay. Let's look at an example. So if these are prime numbers that are only divisible by 1 and the number itself. So why don't we include 0 and 1 in this set of numbers? Please, no set of numbers are if you are and know the basics, you define it. Okay, you even prove, can 0 be a prime number? So let's prove number divisible by 1 and the number itself. Okay, so when you say 0 divided by 1, the answer will have it is 0. Now let's go when you say 0 divided by 0. This doesn't exist. Syntax error. So this is math error. There is no number where you can divide the 0. There is no such mathematics. So you see math error. When you divide any number here, it's supposed to be 2 and you divide by 0. That won't prove. So 0 is only divisible by 1, but not 0 itself. So 0, have you understood why 0 we are not including it as a prime number? Yes. So let's call it 1. It is 1 and the number itself. So 1 is the 1 and it is the number itself. So 1 is only divisible by 1. So we have only one number. So no wonder 1 is not a prime number. Okay, we go to 2. 2 is divisible by 1 and 2 itself. So no wonder 2 is qualifying to be a prime number. 3. 1 can go into 3. 3 itself. 1 can go into any of these numbers and themselves. Now, 9. Here there is a misconception between 9 and 7. Okay? So here, why haven't we included 9 here? Prime numbers. No wonder the question is very pusha sana based on this set of numbers, because they know you either include 9 in here or you won't include it. Now, odd numbers, you either leave 9 in here or you include it. But remember my definitions. You can research further. And understand more, because we learn from others. Okay? Now, why haven't we included 9 here? Let's prove. We've said that prime numbers are numbers divisible by 1 and the number itself. Let's try to put 9 here. If I may ask, what numbers can go into 9? We cannot say 0 because when you divide 0, it's math error. So we'll start with 1. 1 can go into 9. You agree with me? Okay. What other set of number? Okay. Even 3 can go into 9. Okay. 3 can go into 9. What other number? Even 9 itself. Now, is this proving that this 9 is a prime number? No. We've said that a prime number is a number divisible by 1, quite right, and the number itself. Hey, where is this 3 coming from? I'm confused. So, this is not qualifying to be a prime number. So, be careful when you are writing this set of numbers. I hope you've understood it. These all sets of numbers. So this all is based on a set of numbers. This set of numbers. So these are sets of numbers that you need to know in this introduction of sets. In this introduction of sets, we've looked at set notation and set of numbers. Further on, we are going to look at set description of sets, types of sets. Then, in that case, you will think we are now concluding this. So let's look at an example based on these sets of numbers. Exam questions. Because if we start talking about these things, it will seem as if that doesn't exist, but they do, and they ask such questions in an exam. Okay? So let's look at this example. So this example is based on a past paper, which is paper 1 mathematics, 14th November 2019. Okay? You can check on that paper, you find this question. Question 10A. Question 10A. So let's look at the example. The question was, set A is equal to this symbol. We've looked at this symbol. All these we've looked at them. This is a set. No wonder that I've included the word set A. Denoted by capital letter. Remember, equals. We've looked at this symbol. There is no struggle. These scaled brackets, sets are denoted by this. Okay? They have included sets of numbers. So, set notations, sets of numbers. Now, they have combined them. We started from set notations. These are notations. I'm able to understand them. Now, sets of numbers. They have included sets of numbers. So, please share this so that we can learn more. We can participate. Okay? So, set A is this set of prime numbers less than 12. Less than. We know less than is feel less. They are not more than. So less than, I don't think we are buying a super weight. Less, we know that it's less. No. So set A is prime numbers less than 12. So these are sets of prime numbers which are less than 12. So the question was, is set A. So let's list set A because this is simple. We've looked at it. It's very simple. So what we're going to say is that, so we're going to start. Let's look at solutions. So let's look at solutions. So we're going to say set A. When you come to describe a set with my friend, you are going to understand, you are going to learn how sets can be described. One set can be described by listing, second by formula, the third one by diagrams. You look at those things, how you can describe a set. You can be given a Venn diagram by John Venn, a mathematician, or you describe sets in any different languages, in set built-in notations, in so many ways. You describe those sets. Okay, so set A is equal to. So now we are describing it. So set A is equal to. Okay, we write KLD. Brackets. We write curved brackets. Okay. Now, prime numbers less than 12. We know that they are not beyond 12, but they are less than 12. Less than 12. Are we going to include 12? Or are we not going to include 12? So, this you come and understand them more. Okay? When you say less than or equal to, so that number is going to be included. When here less than or equal to, greater than or equal to, that number will be included. Don't want to propound more. What we need is your participation and you to share this so that we can have many people asking many and different kinds of questions so that you can learn and even us we can learn. Okay? So this number is not going to be included this 12. So we have prime numbers less than 12. Okay. Prime numbers we know and we've learned. This is a set of numbers, okay? Now, how are you going to define it? We define the prime numbers as numbers that are only divisible by 1 and the number itself. Okay? So now prime numbers less than 0. So if you start, how am I going to list it? Is 0 a prime number? No, we've showed that 0 that is not a prime number. Is 1 a prime number? Is 1 divisible by 1? 1 is 1 only. So it is not a prime number. Let's go to 2. Then 2, yeah. 2, 1 can go into 2. And even 2 itself. So 2 qualifies to be a prime number. So we write comma so that we separate the two because we have different types. Same applies with calculators. If I say sharp, Casio, I'll put a comma because they are different from different industries and companies. Okay? Let's go to 3. We are saying numbers only divisible by 1 and the number itself 3. 1 can go into 3 and the 3 itself. So 3 qualifies, okay? Okay, we go to 4. Can 4 be a prime number? Okay, 1 can go into 4. 2 can go into 4. And 4 itself, no. 4 cannot be a prime number. Let's go to 5. 1 can go into 5. And 5 itself, someone might think that, what about 2.5? 2.5 can also go there. Why are we including that as a prime number? So it is beyond our scope. It is beyond our scope because someone might reason, what if I divide by 2.5? Or 5 divided by 2? It will give us 2.5. Now, it's not 2 going there. But we are saying that only 1 and the number itself. But just follow the definition. Don't be confused. Okay? But reason like that. It's good to reason like that. Okay? So 5 we're going to include it. Okay? 6, no, 6 is an even number. So even numbers, why we are not including even numbers, then there are many types of different numbers that can go into them. But here we are considering only the 2 numbers. We are saying 1 and the number itself. For even numbers, you can say, oh, can 6 be an even number? Yes, 1 can go there, 2 can go there, even 6, maybe 3 times. So here we're looking at prime numbers. No, so 5 and 6, no. 7, only 1, and 7 itself can go there. Okay, so 7 and 5 is here. Let's go to 9. Can 9 be a prime number? Can 9 be a prime number? We've demonstrated that the answer is possible. No. But why 9 is not a prime number? We've said it's only 1 and the number itself. If we say 9, I've demonstrated once again. If we say 9, so okay, 1 can go into 9. Okay. Even 3 can go into 9. 3. Even 9 itself, which is given 1. So the number which is only divisible by 1 and the number itself, what we are codifying is this. 9 divided by 9, 1. A that number divisible by 1 and the number itself. So 9 divided by 9, it 1. Which is codifying our definition. When we say 9 divided by 1, 9. So no wonder definition is that number divisible by 1, which is 1 here, and the number itself, which is the answer, 9 itself. So have you understood that definition and where it is coming from? We divided by 1. It is giving the number itself. We divided by 9. It is giving 1. No wonder we are saying number divisible by 1 and the number itself. Okay, we move on. 9 is not an even number. So we are sticking to this number. They are less than 12. We are not going to include 12 because we've said unless there is equal to or greater than or equal to. Unless they have included the word equal to. So here 9 we are not going to include it. Let's go to 11. 11 we have only 1 and 11 itself. Okay, 11 itself. Now the numbers are less than 12. If we were to include 12, if there was less than or equal to, are we going to include 12? This one, are we going to include 12? Is 12 a prime number? No. Even if they had to add equal, less than or equal to 12, we're not going to include it. Because this is an even number. It's a natural number. It can be a whole number, but not a prime number. Okay, so less than 12. Meaning, we've listed the set. So, that is the end of our, this is the final answer. That's the final answer. So, mathematics is a simple language. It's a human language that we do all learn and we understand. So, this mathematics is not very difficult as you may accord it. Society perceives it as a difficult subject. So, please, if you are a parent or you are, okay, you are just a player like me, please do share to friends, family, cousins, so that they can learn, have this opportunity. It is a free tuition. We've sacrificed so that we can learn freely. It is not like, okay, we're going to pay this, you are going to pay us this and this. No, it is free. You participate. No, I think this one should be included. We debate, we know, we are here to learn. It's not that I'm perfect, no. And I'm inferior than you because you know much than me. So, but we are here it's because we want to learn, we want to explore our minds, we want to know these things. So, please remember to share. Share this page. It is your page, it is my page. It is my responsibility and your responsibility because learning doesn't end. Albert Einstein said, once you stop learning, you start dying. So, we know that we suffered a lot and we had no privilege to learn. We were in society, but as we stopped learning, we started dying. But now, why not? Because we are here, because we are starting to learn. So please remember to share this page. Share, please, we are begging you to share this page.
That was interesting, fantastic.
Thank you so much.
It's good that now I'm even able, pardon me, it's now that I'm even able now to solve past papers. 2019, just last year.
Yes,
Last year, I'm able to solve it just as clear as you have explained here. I'm now overexcited with joy actually because these things, I thought, prime numbers. And many of us might think that we are prime numbers. Because prime numbers less than 4. Now what are prime numbers? You've explained them here and we have an example. And this is how clear it is asked in the exam. So we have this platform to learn. And sooner or later we'll be able to answer just the entire paper. Yes, very much. So guys, as I said earlier on, share the page. It's not that we are teachers. We are not teachers. We are also learners actually. So we will learn from you and you also learn from us. Just participation.
Participation is more important. I totally agree with you because these things, okay, they might look simple, but these are examinable questions.
Yes.
They are examinable questions. They are examined. So it's good that we played with you. So make sure that you share this. So that even others, let us not be selfish. We share to other groups so that they might also see this kind of tutorial. So
Yes,
guys,
this is the foundation of mathematics.
Yeah.
If we are able to understand such things, we have a background, a foundation.
Exactly.
Even as we go to higher topics, those topics that require a higher knowledge of understanding, it will be very easy because some concepts will be gotten from this illustration.
So these are concepts that we're going to stand and create. And in fact, you know what? Okay, I've seen so many past questions. So, the time I didn't know these things that they might come in an exam, I was wondering, what are these things? And if I heard my friends, those things are difficult. Those are what and what. So, okay, let's hear them. So now, this platform has given us a privilege.
Yes, a privilege.
Simple.
Because if you were at home, we wouldn't have learned this.
Yeah.
But we have a platform to learn. So, guys, share the video as many people as you possibly can. So that we interact more. We have many viewers to participate and also debate on the answers. If you have an alternative way, feel free. You can say, no, okay, here I thought it's supposed to be this way, and we will negotiate and find the correct answer.
Once again, we are thanking you for spending this privilege. Thank you for your time. Thank you for your precious time. We know that we've wasted your time, but as I know, it is not the wastage of time. Because time wasted is never recovered. We thank you for spending your time being with us. So we thank you. Like the page, please share, and invite other friends so that they might see. We thank you for your time. May God bless you all. Thank you.